Hi, Jim Quancy here. This is part 7 of 7, our last part of an introduction to Forge. The use of Forge for part of enabling companies to do digital transformations, making design and engineering data part of a company's digital transformation, just as much as a company may be using ERP, CRM, various collaboration systems, various file sharing systems as part of their digital transformation. And in this area, this video, I'm going to talk about configurators in design automation. Configurators typically done during a sales process, whether by an outside customer, the end user itself, or by a sales engineer, or someone in the engineering department to kind of automate tasks. And I'm going through design automation because they're related. Automating tasks and configurators cover a lot of the same ground, and it's a lot of the same technology. So I'm going to talk about both of them during this video. Again, before I get started, for those of you who this is the first Forge video you're looking at, just recognize Forge is a set of web components that's used for building all kinds of solutions. And here's some of them: data visualization and analysis, digital twins, AR, VR, XR, MR, depending on what you call it, various SaaS integrations, catalogs, specifically spare parts catalogs, and then, as we're going to be talking about today, configurators and design automation. And I'm going to run a little video here, and or am I going to a website right now? We will see a basic configurator, in this case for Windows, from Geldwin, who's one of the largest manufacturers of windows and doors in the US.
We came out with a platform that's being integrated into our website. So our website will contain a fully configured on-the-fly Forge model. We have trillions of configurations out there. We have thousands of product lines. So how do we get all that information together into one place? And how do we deliver that to those that need it, when they need it, how they need it, in a timely fashion? Commercial builders.
So that's one example of a configurator. And now most of these configurators behind the scenes have a CAD engine. And the Forge Design Automation API has been around for a couple of years with AutoCAD, but we've just recently added Revit, Inventor, and 3D Max as CAD engines. So now we have these 4 CAD engines. These are the full CAD desktops as people are used to using, but without a user interface, so they can be driven programmatically. And let's go look at a few more videos on the types of configurators, the types of automation that partners are doing. And here's an example of a company, CADcraft, and typical simple configurator. You enter some data, you hit apply, the engine in the background does the design for you. In this case, it's a balcony. And the interesting part with this configurator is that balcony Revit content, a Revit family to go in a building? Or is that a mechanical CAD? Is there an Inventor in the background, creating a design and an assembly, allowing very quick customer quoting, and then sending all any detailed information to the factory floor to have it built? And we have examples of a number of configurators that they do both. They deliver Revit information for the big picture design, and they deliver the actual detailed mechanical manufacturing information for the actual fabrication. And you could see here we actually crank out drawings. Yeah, models are good, but sometimes what the answer is drawings. And here's an example of there was a complete assembly, sub-assemblies built in Inventor, because maybe part of the process is done by a customer or a sales engineer, and then that design is further detailed by someone in-house in the manufacturing area. And let me do another one that's around Inventor. And this is about drainage. This is a web application done for one of our customers, ADS design tools. And the ADS is Advanced Drainage Systems. So this is for a quite technical customer who brings in a PDF file, a drawing, where they're then going to design the drainage system. And the interesting thing is the drainage system is actually going to be designed behind the scenes in Inventor so that it can be very quickly quoted and go to the shop floor and shipped. So very quick customer experience specification to real revenue for ADS. So this is all just HTML. It's just a web page. Entering parameters. They've got a little graphical representations of what the drainage system would look like that they're overlaying on top of the PDF. And if you're watching closely, they went through it pretty fast. There's a little scaling routine went on. And again, so quite a complex design process happening on a web page that in the past would have been a desktop app. But again, all the beauty of cloud that when enhancements are made in this design experience, everybody gets it. Everybody has the same capability all the time. You don't have to worry about installs and distribution and all the issues you have with heavy client-based kind of applications. I'm going to let this run a little bit. You can watch this design process taking place. Has quite a bit of UI and input for the user involved. But you'll see when we get to the end, hey, there's a real model, there's documentation, there's that ability to go from a customer inquiry to a real quote to a real order being very, very fast. Taking what used to take weeks and back and forth between the customer and sales engineers and salespeople um, gets done in, I won't say a minute or two, but 10 or 15 minutes, and the user knows what they have. And the supplier, ADS, Advanced Drainage Systems, knows they know exactly what the customer wants, and something wasn't lost in interpretation. You can see here there's a request for drawings. And in a second here, you'll see, I think it's an email shows up and it's got links to drawings and kind of everything you want. And we're almost there. There we go. So an email was sent to the customer, drawing package, BOM spreadsheet. Now for this drainage system done by a civil engineer, these drawings are not just for the customer to go, yep, that's what I want, and not just for ADS's shop floor to make sure the right thing is built. It's also for submission to a local government to get planning approvals for permitting purposes. And as you can imagine, this, dramatically, speeds up, the clock time from when somebody makes an inquiry to the time there's actual the shipment, delivery, and billing, while giving the customer really deep confidence and delight in that the control they have in the reduction of surprises. Okay, so we're going to go to some live websites now, and live websites are always fun. And let me do a refresh here. A lot of these websites, these web apps, for authentication purposes, you have to refresh the keys every once in a while. So when I, have this running in the background, I know I may have to do a refresh if I haven't used it in a while. So here's a building, and this building, might have been done with Revit, or it's an IFC file or MicroStation or AutoCAD, whatever it happened to come from. Doesn't really matter. It's, we're using the Forge viewer here, as the interface. I'm going to click on a place on the floor, and I'm going to place one of these racks. And this is an example that we actually built for a customer that sells racks. And, their big customers are data centers. And data centers want help applying the product and then frankly the start of a again sales process in a very powerful way for the user. And let me pick another place on the floor and we'll throw one of these other pieces of equipment and I'll go in here and we'll do something a little more interesting because it's not just placement, it's things like I want to move. So I've got a little move widget here, and this is a little bit of a geeky widget because this is a technical proof of concept. It's not a polished end user application, but the idea in a web page, oh, I don't want to grab the building, I want to grab the piece of equipment and move it. Or maybe I want to rotate that piece of equipment. And, I get my little rotation widget and, I can change the rotation, right? So you get the idea. Very simple kind of configuration experience. And when we started here, where they went was, starting to create capabilities for spacing racks, spacing aisles between racks, and there's all kinds of regulations around that. Here's another example we did for a partner, a large manufacturer of heating and cooling equipment, and they do business worldwide. And you get these heating and cooling units that go on a wall or go on the floor, not centralized, but kind of localized heating and cooling. And again, we may have to wait a sec here while I do that refresh to make sure all my keys are up to date. And again, a model here that might be from AutoCAD, might be from SketchUp, might be from Revit, probably Revit. Knowing where my folks who build these examples come from. But what I'm going to do here is I'm going to pick a piece of the wall and I'm going to place this unit, right? And there's the unit on the wall. And in fact, I'll have some fun here. This unit at the bottom is a floor unit. So I'm going to pick the wall and try to place a floor unit. Okay, so it says you need to select a point on the floor. So you can add logic in this to kind of help people along. So I'm going to pick a floor and we'll place that floor unit. And there's the floor unit. And like I did in that other example, I'm going to reach in and grab this unit and we'll do a little, we'll move it, right? Because I want the unit to be here or here, or, maybe I want to farther up the wall. So I think you get the idea, relatively easy to, create these simple configuration experiences. Let's go back to my PowerPoint. We've kind of worked our way through all of those and that one. Another configurator. This one's on the Inventor side. And it may be hard to tell what's going on here. I'm adding platforms and steps and ladders in this kind of 2D web page environment, right? It's schematic. But what's happening is this is creating a model. There's Inventor in the background. This is a project, and here is the model. Very quick, very easy. For this manufacturer of these kind of platforms, being able to deliver this kind of experience to their customers is absolutely great. The other thing is this application, the customer of ours, the manufacturer of the platforms, already had an application they were using in-house. And I think it was an iLogic-based application that their sales engineers would use. So being able to give this capability to their users, again, to speed up the time from the user saying, hey, I need a platform of a certain sort, to knowing exactly what the customer uses, where you can say, okay, time to make the purchase. This is powerful stuff. And don't discount the fact when you give the user more control, it gives them more confidence. They actually get more emotionally engaged with what your product is because they've put some time and effort into it and they have a high degree of confidence, a much higher degree of confidence they're going to get what they want because it hasn't been through kind of 3 levels of interpretation. And again, clearly this is really good for the manufacturer because they know exactly what the customers want and they have the assembly and it's all ready to go to the shop floor without their having kind of costly engineering talent interpreting what the customer wants and building the models. And let me keep going here. Just another example, different kind of configurator. I thought I would bring up, and in this case, I'm not going to show you an app. I'm just a blog posting that talks about area planning in a collaborative way from a web page. We're actually several different companies that share a space. In this case, we did this for a large retail store that has shared spaces from their suppliers. And it allows their suppliers to go in and say, hey, I want this space. And they see exactly where it is on the floor. They see the square footage. And for the company, the retailer that owns the whole overall space, they really want to know who's got what space because this feeds right into their productivity, their metrics, their financial metrics on what's the return on investment per square foot of space given to a certain partner of theirs that has space in their stores. So pretty cool stuff. So though many examples are 3D, sometimes the configurator experience you're trying to deliver is 2D. And let's go back. So these configuration experiences, again, these are the primary Forge services. And what you saw at work was data management API, pushing and pulling files back and forth, frequently in this case, passing a file, whether that's data or whether that's a CAD file, to the design automation engine. And then the design automation engine, again, whether that's AutoCAD, 3ds Max, Inventor, Revit, then does the work. And when the work is done, it gets passed to model derivative and the viewers, so the person who's doing the work can get this immediate feedback on, oh, so that's my design that I just, configured. And I can look at the model and, using classic viewer capabilities, I can take it apart. I can look at parts. I can look at 2D, 3D. I can share that information with other people because it's just a web page. Okay, so that was mostly configurator side. And what I'm going to do now is dig a bit deeper on the design automation side. And again, these are the four engines. And do think of them as a collection because we do have people who are doing things like building product manufacturers who will actually use Revit, Inventor, and AutoCAD engines. And I saw one recently uses all four engines, right? Because they need to deliver a Revit family or some content that's BIM centric, and they need the detailed information from Inventor to pass for fabrication. They've got these drawings that need to be done, and for getting review. They're using AutoCAD for that. And they may be using Max because they also want to give the customer a photorealistic, beautifully rendered view of kind of the product in place, where all these tools come together to do that, right? All from a web page, no CAD system in sight. So let's look at some other kind of examples of configuration. We'll start here with Philips Lighting, who was working with one of our partners in the Netherlands, Synapse, to create a website where lighting engineers, electrical engineers, can go shop for different kinds of lights from the Philips Signify catalog. They can place those lights in a building. This is on a web page. They can calculate things like lumens. Are they getting enough light for the various office spaces that meet local regulations? Using tools to actually lay the lights out in an automated way to a grid, doing power usage calculations, and then feeding the whole thing back into the building information model into Revit and saving the new version back into BIM 360 where collaboration and sharing of the results are being done. All tied together. Pretty slick stuff. So we got manufacturing, Philips, we've got designers on the lighting side, architectural people, customers seeing results, and the whole collaborative team being able to take advantage of this highly automated experience that used to take 3 or 4 tools in several hours and now can be done in minutes. Okay, another example of design automation at work, looking at a piece of land or looking at land in a geographic area and trying to figure out how big a building can I put there? Understanding setbacks, understanding cores, understanding height limitations, and using generative design to throw out a whole bunch of examples and calculate, how much rentable space do I have, square feet, square meters. So very early in a project, starting with a piece of land in a specific area, I can get an idea on return on investment in minutes. Again, rather than what happens today is you put days or weeks into a single piece of land only to realize the return on investment may not be good enough. This allows a much more quick, easy exploratory approach to things. Design automation systems. Hey, one of our partners actually specializes in building these automations. And it's funny, they've built the same app twice, once in Inventor, once in Revit. And as I mentioned earlier, depending on who the target user is, you may need an Inventor model to pass to manufacturing. You may want a Revit model to get passed into a larger Revit project. And here's this framing design that was done using Inventor on the cloud. Now, this is framing of a container, and I'm going to click down here because I'm going to go to the next one that Design Automation Systems has done. Create module and same kind of thing. I enter basic dimensions. Um, Only instead of Inventor, now it's Revit in the background, um, churning out what will be a Revit model of very similar framed module. Um, and this will come here in a sec. Little patience here. But it is funny seeing this same designs being done with different engines because of the different use cases. And reality is, as someone, if you're building a configurator, that idea that you have a central pool of data that you can use to create different representations, right? A manufacturer module, um, a BIM, drawings, and maybe a beautifully rendered. Okay. Now here's another cool, and this is kind of the beginning. It really makes hopefully get you thinking. This is a web page with a grid, with snapping. What's happening here is what was outlined was a floor plate and walls, and that was sent to Revit. And now we have a BIM, we have a Revit model built on the fly on a web page. Um, and now, passing in the furniture and, there's widgets here for moving things, aligning things, rotating, very simple layout. Now, don't get me wrong, this isn't kind of Revit on a web page. But if you need to build a web experience such that a customer or a sales engineer could use kind of in real time to do simple kinds of layouts, to do conceptual design work, I mean, you can absolutely do that, and it's just not that hard to do. Another one, just simple changing of Revit parameters, checking Revit parameters, pulling them out, making changes to them. Those of you who are BIM managers, VDC managers, you know the point. You've got maybe you're going through a project, you want to see if the parameters are missing, and maybe you use Excel to do that. Maybe you use some database to do some checking. And when you see parameters missing, you want to update those parameters. Um, and the person who's actually doing parameter checking, maybe it's things like fire rating, and it may be someone who's not a Revit user, not comfortable in a BIM environment, um, but has expertise and knows what to look for. Or again, maybe you're just a BIM manager, a VDC manager who wants to have an easy, simple way to check and fix parameter problems. Because if parameters aren't right, you end up with a dumb model. The IM BIM isn't effective, and that can impact your ability to schedule. That can impact your ability to cost. Um, and I'll let this continue to run a bit. You can see here the parameter information has been pulled into a spreadsheet. Changes are going to be made, and then they'll be pushed straight back into the model. A lot of applications that are QA-like, doing quality checks, because again, the power of BIM requires consistency, requires data, and you have to enforce that, whether within your own team or whether with subcontractors, whatever it may be. I've also seen this kind of workflow being used for people who are getting ready for operations and maintenance, and they need to connect the BIM with their operation and maintenance information. And again, the parameter data needs to be right. And if it's not, it's kind of, dumb in, dumb out. And I think we are just about there. Yeah, looking through the model browser to see some of the kind of information that was updated through this kind of automation process. And we'll keep moving here. And again, what have we seen? Data management at work, moving files around, the design automation API, the engines, model derivative and API, and the viewer, so we can actually see the result and validate, what happened. And in some of these cases, the data was residing in BIM 360. So information started in BIM 360, got processed, and ended up being pushed back into BIM 360. Okay, for design automation, whether it's configuration or just pure automation, maybe internal processes, I want to let you know we did these, and it's like hour-long videos for each one of the engines. AutoCAD, Revit, Inventor, Max gets into the details of working with each engine. So if you're a software developer, I really encourage you. If you just go to Google and you do Autodesk Forge, design automation, name your engine, YouTube, you will find your way to these videos. Getting started, again, if you're a software developer, full stack web developer, and you haven't worked with Forge before, learnforge at autodesk.com, not .com, .io. We've got a full tutorial here. You know, you can get through this tutorial, in maybe a day or two, and it starts with everything from authentication, getting your license, through to passing a file, simple viewing, integration with BIM 360, working with design automation engines. It's all right here, and it's quite straightforward to use. I will say when you're doing these configurator and design automations, there's the cloud side, the web side, which a full stack web developer will be comfortable with. But there's also the desktop APIs, right? The Inventor API, the Revit API, the Max API, the AutoCAD API. So it might take two people, one with expertise on each side, to build these kind of configuration experiences. Now, the last thing is do not be bashful. Ask for help. Forge.help@autodesk.com. Direct email to my engineering team, goes right into our case system. You will get an answer in a day or so. You can ask a specific question, or you could just ask with, hey, I'm getting started and I want to talk to someone and kind of get situated. Really help you climb the learning curve really fast. So don't be bashful, ask us. Now, if you are a bit bashful, you can just Google search your favorite way of learning. Autodesk Forge GitHub, Autodesk Forge Stack Overflow, Autodesk Forge blog, Autodesk Forge YouTube, which you may have already done, which is how you got to this video. But there's lots of information up there, and there's lots of different ways you can learn. And of course, there's the formal documentation, pricing information, customer success stories, and more that you can find at the Forge website, forge.autodesk.com. And with that, I'm finishing up. This is my last video, part 7 of 7 of Forge. I hope you've enjoyed it. I hope you've enjoyed several of them. And have a great day.